All right, let's look at the homework 5.4, problem number 9. All right, suppose that a volcano is erupting and the readings of the rate R of t at which solid materials are spewed into the atmosphere are given in the table. All right, so this is the rate. And time t is measured in seconds, and the units for R of t are tons, metric tons per second. All right, so part A, given upper and lower estimate for the total quantity Q of 6. All right, so you can think of estimating the area under the graph of R of t from 0 to 6. All right, so let's do that. So from this table, looks like the R of t is constantly increasing here. So if you use the left sum, it'll be a lower estimate. If you do the right sum, it's always going to be the upper estimate. All right, so let's do that. So I'm going to just, all right, so the interval length is 1. So delta t is 1. So let's see. So first interval, you use 2. And next one, 10 plus 22 plus 32 plus 48 plus 52. Right? Then interval is 1, so times 1, which doesn't really do anything. So delta t is 1, so hit enter. So this comes out to be 166. All right. If you want to do an upper estimate, we're going to do the right sum. So we're going to start with 10 plus 22 plus 32 plus 48 plus 52 plus 60. All right. Then times 1. Times 1. All right, and it came out to be 224. All right, and for the midpoint rule, we have to use the two intervals in one shot. So from 0 to 2, midpoint would be 1, so it used 10. From 2 to 4, midpoint would be 3, so we use 32. And from 4 to 6, midpoint would be 5, we're going to use 52. All right, so what we're going to do is we use 10 for the first rectangle, and the 32 for the second one, and the 52 for the third one. But we multiply by 2 since we're using 2 interval in one rectangle. So if you type that in, 180 and 188. All right, so that's the midpoint rule to estimate the Q of 6. Let's check. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.